Yes, now let us see what is the relationship connecting nearest neighbor distance, edge length, and radius of the atom for pure elements. Okay, it's not compound, they are all pure elements. Okay, whether it is in simple cubic close packing or face centered or body centered, whatever be the lattice, what is the relation connecting these three? Okay, now what is D? D is nothing but nearest neighbor distance. Nearest neighbor distance का मतलब क्या है? Say for example, here I have taken SCC. Now these two atoms are touching each other, is it not? So the distance between the two, that is distance between the two कैसे calculate करोगे? Center of one atom to the center of another atom, the nearest, the closest, that is which is in touch with each other. Okay, so that is called as nearest neighbor distance. Okay, now in the case of simple close packing, you will find that this is nothing but side of the cube, and side of the cube is nothing but A, and A is nothing but nearest neighbor distance. So D is equal to A. Right, now look at FCC. Now this is FCC lattice, right? You have, this is one phase I have shown you, right? Now nearest, it's a pure element, okay? Now whatever is there in the corner, that is the same atom which is there at the center also. So your nearest neighbor distance will be from this point to the center of this. This is your nearest neighbor distance. Supposing you consider this AC. What is AC? AC is 4R, is it not? R plus R plus R plus R. Because it's nothing but phase diagonal. Okay, so phase diagonal is nothing but 4R. And according to Pythagoras theorem, AC square is equal to AB square plus BC square. All these things we have already done. So your AC square will be 2A square. So AC will be root 2A. Okay, right. Now what is ACC here? This is your AC. And nearest neighbor distance is what? Half of it. Okay, so whatever you find out as AC, uska आधा है nearest neighbor distance. So it is D is equal to half of AC, right? Half of AC. समझ आ गई? ठीक है, तो AC क्या है हमारा? √2A. So √2A upon 2 will give you distance, right? Nearest neighbor distance आपको दे देगा. Now if you solve, you will get D is equal to A upon √2. How? See, you multiply √2 and divide by √2. √2 into √2 is √4. What is √4? √4 is nothing but 2. और वो 2 और ये वाला 2, ये दोनों कट जाएंगे, तो नीचे बचेगा √2. So it is A upon √2. That is why D is equal to A upon √2. Now the next one is BCC. Now in the case of BCC, you see here, now this A and D, it is a body diagonal from this corner to the opposite corner, right at the bottom, top corner to bottom corner. And what is this BD? BD is face diagonal. AD is body diagonal, BD is face diagonal. So triangle ABD, if you consider that's a right triangle, based on that you have calculated that A is equal to 4R by √3, which we have already done. We have done this relation between A and R. Okay. Now from this what you can say, R is equal to √3A by 4. Right. Now what do you want? You want nearest neighbor distance. Now in the case of nearest neighbor distance, what you have? You have the corner atom and then the central atom and then again this corner atom. Right. This is your central atom. This is your corner atom. This is another corner atom. Okay, or you take this one. So here what you find, this corner to this corner, it is again 4R. Okay, now nearest neighbor distance is what? 2R, right? Here you are having R is equal to √3 by A. So what will be D equal to? D is equal to √3A by 2, because it's half of that, right? That's it.